In this segment, I want to get into Wii RAM hacking. Now, I've covered the USB GECKO in previous segments. If this is the first time you're hearing about it, it is a device that was created for the GameCube and the Wii that plugs into the memory card slot and allows you to have a USB interface to do various debugging and development features. It's really great for homebrew, and if you have a real interest in any of the GameCube or Wii homebrew, I'd highly suggest getting one. Now, before we even begin, we have to have a slight understanding of the inner workings of the Wii. The Wii itself has 88 megabytes of memory. Only 24 of those megs we're really interested in. The Wii does partition the memory into a Mem1 and Mem2 range. I'll put some links in the show notes that explain the memory ranges of the actual Wii itself. I'm not going to get into it today. But you have to understand that there are certain ranges of addresses that if you poke at it, it'll instantly crash the Wii. Reason being is that the Wii does have encrypted parts of RAM. There are two main CPUs inside the Wii itself. You have the Starlet, which when you first power up the Wii, it sets up all of the communication, the encryption, it sets up the controllers, it sets up the entire environment, and then makes sure that everything is a secure session, everything is encrypted throughout the ass and back again. And it puts itself into small ranges of memory. Now, once everything is authenticated and secured, it hands control over to the Hollywood CPU, and the Hollywood CPU will execute the code and let you play your game or your homebrew. Now, the problem with this is if we actually read or write to any of the contents of RAM that the Starlet's execution code is in, or is residing in, or any encrypted RAM for that matter, it'll instantly lock up the game. Also, you can peek into not only the actual RAM for the system RAM, but you can also poke into the graphics RAM. So sometimes a game might be using system RAM to hold graphics data, and just by reading it, causing that lag, when you dump the data, it's going to crash the system. So when you first get started, do a lot of research on the USB GECKO forums. There's a whole community of RAM hacking people behind this, and they've got a lot of great information already out there. I'm going to link to them. We'll put it in the show notes. Now, before we even get into the actual console side, we have to understand object-oriented programming languages. Now, typically with NES hacking, the game itself actually resides on a flash cartridge. Everything is all in that one area. And we always know that the RAM addresses are always going to be the equal no matter what, no matter whenever we load a stage or wherever it's going to be, everything's on that media. But today, games are held on CDs or DVDs. There's no way to put like a 700 meg CD in the contents of only 88 megabytes of RAM. So when we have a 3D game, it's what we call an object-oriented language, meaning everything in the entire game is considered an object. Like an example, let's say that my entire room here is a computer simulation. My remote control is coded and compiled as one object. My laptop here is one object. I am an object. The camera is an object. The tripod stand, an object. My tables, they're objects. Those objects will load into memory, and in those objects themselves will contain actual memory locations. Now, when the game's loading things in the memory, today we're going to focus on Super Mario Galaxy for obvious reasons, and I'll explain in a little bit. Now, when the game is actually loading in the memory, the first thing that should load is the stage. So sometimes the stage could be 5 megs, maybe it could be 10, maybe it could be 50. You don't know until it loads. So when Mario finally, which is going to be the obvious character you want to have your attributes for, when Mario loads into that level, the memory addresses in which his health and his lives and star bits and coins will never be in the same location twice. This is an obvious thing for any object-oriented language, because when things load into memory, it goes first in, first out, or what's called FIFO. And the FIFO buffer basically means is the first thing that goes into the RAM is the first thing that comes out of the RAM. So the first thing that goes into the RAM is going to be the level. So if the level takes up, say, 10 megs of space, and then Mario takes up, as an object, takes up 1 meg, he's going to be at the 11 megabyte mark. But what happens if your level takes up 15 megs? Mario will start at the 15 meg limit and take up 1 meg. Argument's sake, I'm just trying to make this easy. So this is where pointers come in. Now, the first thing that really loads to RAM is what's called a pointer list. So think of it like this. If a game is compiled as an object, and each object is like a book perhaps, where there are chapters, you might not know where those chapters are unless you manually look through. But if you look at the index of the book, it'll tell you where all of the chapters start on what page numbers. That's what a pointer is. The pointers are an actual list of where the actual object will reside in RAM, and where in that object file, in a memory offset, where to actually find specific values like health, coins, what power-ups you have, and a whole bunch of stuff. So typically with the NES RAM hacking I've done like 20-something segments ago, we just basically would dump the RAM and we'd compare and contrast, and we'd look for different differences in values, like, you know, more than, less than, equal to, not equal to, specific values and such. So go back to those segments and check out the basic techniques for RAM hacking. Those will be applicable to this. Today, I'm going to get a little bit more in depth. I'm going to automatically understand that you have a clear understanding of binary, hexadecimal, as well as the decimal numbering systems, 8, 16, and 32-bit string formats and variable formats. I'm automatically going to assume that you know the basic concepts of how to dump the RAM, use a utility to compare two sets of RAM to find the differences, to find the addresses you're looking for. All of that I'm going to assume you already know. If you don't, hit previous episodes. I'll put links in the show notes on basic concepts of that. So we're going to go and load up Mario Galaxy and the Gecko OS, and we're going to get to the PC side and get to a brief tutorial on how to start Wii RAM hacking using Super Mario Galaxy. Go ahead and load Gecko OS by way of choice. I plan on using the Wii Homebrew channel, and launch the weird graphical user interface. It'll automatically launch the game. So, brief overview of what you're seeing in front of you. The interface has the next step and run button. Once the game actually loads, you can either hit next to go and increment one CPU cycle, or you hit run to resume the actual game itself. If at any time you need to pause the game because you're in heavy action or just whatever reason need some time to think, you can go ahead, hit the pause button. Top left, we have the memory ranges that we're allowed to play in, which I'll put some links in the show notes about. And it also automatically fills in the start and end addresses that are safely allowed to actually play in. Now, we can actually do a search of a value type of an unknown value using, you know, the particular equal, not equal, less than or equal, you know, the typical, you know, compare types. Or we can actually load, we can search for specific values of either 8, 16, or 32-bit values. Later on, we'll be using the pointer search, the memory viewer, as well as the GCT codes, but we'll get into those when the time comes. Go ahead and load up Mario Galaxy and get to the primary observatory place, and if you notice on the screen, I have 9,852 star bits, so we're going to go and start searching for things. So we're going to search for a 32-bit value of 9,852. Now, of course, this is in decimal, and we want to work in hex, so we hit the convert decimal to hex button, and it'll convert it to 267C. We're going to go ahead and start. It'll take about 45 seconds to dump 24 megs of data, and the Wii is going to lock up, it's going to freeze and make a horrible bunch of noise, so mute your TV, and then just bear with us. Alright, the search is done, and we are left with only 6 codes, which is pretty good. Every once in a while you'll have a couple of tens of thousands. So we're going to go ahead and we are going to use 2 star bits, and we are going